Good afternoon, students. Good afternoon, students.
Good afternoon, ma'am.
So, yesterday we have seen how to solve a system of homogeneous equation using Puzzle algorithm. Now we will see how to solve non-homogeneous system. Okay. So for that we will consider a direct theorem. We will take theorem 4.3. Can you hear me? Can you hear me and can you able to see the screen?
Yes, ma'am.
Okay. The solution of equation u at t plus 1 is equal to au of t plus f of t, satisfying the initial condition u at 0 is equal to u0 is u at t is equal to a raised to t u0 plus summation s is equal to 0 to t minus 1 a raised to t minus s minus 1 f of s. So this one is non-homogeneous system. In previous lectures we have seen the solution of u at t plus 1 is equal to aut only. Okay. Now if it is non-homogeneous means plus f of t, u at t plus 1 is equal to a times u of t plus f of t, then its solution is given by this one. We want to show its solution is given by this one. Okay, so we will prove this. Something is a solution if it satisfies that equation. So if I show this solution satisfies this equation, then I can say that this is a solution. Okay. So it is enough to show that. We will give number 1 and 2 to this. It is enough to show that equation 2 it is enough to show that ut given by 2 satisfies equation 1. So consider u at t is equal to a raised to t u0 plus summation s is equal to 0 to t minus 1 a raised to t minus s minus 1 f of s. If u of t is this one, t plus 1, what is u at t plus 1? Just replace t by t plus 1. It will be a raised to t plus 1 u0 plus summation s is equal to 0 to t a raised to t plus 1 minus s minus 1. So only t minus s and f of s. Is that right? So now if I take a common, what I will get? A raised to t u0 plus summation s is equal to 0 to t minus 1. Now this will be okay. Before going to that step, let me write a raised to t plus 1 u0 plus summation s is equal to 0 to t minus 1 a raised to t minus s f of s plus last term is what? What is last term? For s is equal to t. S is equal to t means a raised to t minus t f of t. Is that right? This summation I have split it into two parts. S is equal to 0 to t minus 1 and last term is s is equal to t. Is that okay? Are you there? Students, are you there?
Yes, ma'am.
So please reply me whenever I am asking something. I can't see you. So if you reply only, then I will come to know you are there with me. Summation s is equal to 0 to t minus 1 a raised to t minus s f of s plus f of t I can write. A raised to 0 is 1. Okay, so it is just f of t. Now from these two terms, I will take a common so that I can write this as a raised to t u0 plus summation s is equal to 0 to t minus 1 a raised to t minus s minus 1 f of s plus f of t. Now what is this? This is nothing but my u of t plus f of t. So I have started with u at t plus 1. We have started with u at t plus 1 and we have shown that RHS is a times u of t plus f of t. Is that right? So the value of ut given by 2 satisfies equation 1. Also, I want to show also what is u at 0. If u at t is equal to a raised to t u0 plus summation s is equal to 0 to t minus 1 a raised to t minus s minus 1 f of s, then what is u at 0? u0 plus summation s is equal to 0 to minus 1 a raised to t minus s minus 1 f of s. But summation s is equal to 0 to minus 1 a raised to t minus s minus 1 f of s must be 0. This is by convention. Summation can't go like previous. S is equal to 0 to minus 1 we can't write. So by our convention we use this. Therefore u at 0 must be u0. Is that right? So from 3 and 4, therefore from 3 and 4 we say that we can say that ut is a solution of equation 1 ut given by 2. Is that okay?
Yes, ma'am.
Is that okay?
Yes, ma'am.
Now we will go to stability of linear system, section 4.2. Stability of linear system.
मैम कैन यू रिपीट वन स्टेप
Yes,
ऑफ मैम वो
yes.
बाय कन्वेंशन थ्योरम से ऊपर की जो स्टेप है ना
आवाज नहीं है
उसमें हेलो
हाँ
हेलो हाँ मैम
हाँ,
वो
बोलो.
कन्वेंशन थ्योरम के ऊपर की जो स्टेप है ना
काय म्हणताय?
हाँ बाय कन्वेंशन यू ऑफ 0
हाँ
वो वाली स्टेप ए ऑफ टी माइनस एस माइनस 1 बोल तो टी 0 ले लेना मैम
हाँ a raised to ओके यस यस यहाँ पे 0 आएंगे राइट.
हाँ
Yes, yes. Since this sum is like s is equal to 0 to minus 1, whatever may be what we say, whatever may be function here, it must be 0. That sum,
Yes,
by
ma'am.
convention, we treat that sum as 0. Is that okay?
Yes, ma'am.
Okay, so we will go to the next section, stability of linear system. So we know that the system of solution of the initial value problem for a system of equations with n unknowns is represented geometrically by a sequence of points like u1t, u2t, unt, t is equal to 0 to infinity. So it is always useful to know that whether that sequence converges, diverges, bounded, unbounded, and so on. Okay, converges means as t tends to infinity, where that solution tends to. Okay, whether it tends to 0, whether it tends to infinity, whether it is oscillatory, or whether it is bounded, and so on. So this all type of study is known as stability of linear systems. Okay, so we can write that the solution of an initial value problem for a system of equation say n equations in n unknowns with n unknowns is represented geometrically by a sequence of points u1t, u2t, unt, and t running from 0 to infinity. It is an infinite sequence in Rn. In many applications, it is always useful to know the general location of those points for large values of t. There are numerous possibilities. Many possibilities, namely, to mention few, one of the possibilities, the sequence could converge to a point, means it is a convergent sequence, or at least remain near to a point, or the sequence could oscillate among near several points, or the sequence might become unbounded, or the sequence might remain bounded in some region, or bounded set etc. Okay, so the study of these all matters is known as, or is called as, stability theory. Okay, so we will discuss in which case solution will be stable, or in which case it will be asymptotically stable, unstable, and so on. Okay, so before going to the thing, okay, we will go to the theorem. Important theorem. Let A be an n by n matrix with spectral radius of A is strictly less than 1. What is spectral radius of A? Maximum of modulus of eigenvalues. Okay, so spectral radius of A is less than 1. Then every solution ut of equation 4.4 is my u at t plus 1 is equal to A times ut satisfies limit t tends to infinity ut is equal to 0. Means at t tends to infinity, all solutions tends to 0. So as t is large, u of t is tending to 0 or tending to origin. Furthermore, if r of a, spectral radius of a, is less than delta, strictly less than 1, then there is a constant c, greater than 0, so that mod of ut is less than or equal to c delta raised to t mod of u0 for t greater than equal to 0, and every solution u of equation 4.4. 4.4 means this is my u number 1 to this. Okay, what this says that if A be n by n matrix with R of A is strictly less than 1, spectral radius of A is less than 1, then every solution ut of equation satisfies limit t tends to infinity, ut is equal to 0. And furthermore, if there exists delta such that spectral radius of A is less than delta less than 1, then there is a constant c greater than 0, so that mod of ut is less than equal to c times delta raised to t mod of u0. Okay, so we want to show this one. So for this, what is the solution? We have already seen the solution of this equation. If all eigenvalues are distinct, then it has n linearly independent eigenvectors. Then its solution is given by a raised to t u0. But a raised to t u0 is nothing but lambda raised to t u0. And since spectral radius of A is strictly less than 1, means each eigenvalue is less than 1. So lambda raised to t as t tends to infinity must tends to 0. So now we have to show here r of A is less than delta less than 1. Then we want to show there exists a constant c. So for that we will fix delta, so that first we will start with this one. For fix delta so that spectral radius of A strictly less than delta, strictly less than 1. Now what is the solution of 4.4? Either A raised to t u0 or lambda raised to t u0. If it is not, then in any case we can use Pazhar algorithm, right? By Pazhar algorithm, the solution of equation 1 is given by we know that by Pazhar algorithm, what is it is given by ut is equal to, what is the solution? Summation I is equal to 0 to n minus 1
n minus
c
1
I plus 1 of
c I
t
plus 1
mi u0,
u naught.
where what is u0? U at 0 is equal to u0, right? And what are CITs? And CI set or and CI satisfies the equation. Which equations it satisfies? C1 at t plus 1, C2 at t plus 1, and so on, Cn at t plus 1 is equal to what? That matrix. What is that matrix?
Lambda 1
Lambda 1,
0 0 0
0 0 0 1,
1
lambda
2
0 0 0 0 1, lambda 3 0, and so on. What is the last one? 0
0 0 1 lambda n
0 1 lambda n
into
into
C1 at
C1 t,
C2 at
C2 t,
up to Cn.
Cn t. Now, what is the relation between spectral radius of A and lambda 1? Spectral radius is always bigger than lambda 1. Are you there?
Yes, ma'am.
Yes, ma'am.
So C1 t plus 1 is less than or equal to spectral radius of A into C1 t. I can write again this. I can write mod of C1 t plus 1 is less than or equal to modulus of R of A, or it is always a mod of C1 of t. I can write. Is that right? Modulus of R of A is nothing but R of A, because it is, what is my R of A? Maximum of modulus of lambda I, where lambda I belongs to sigma, right? Sigma of A. Sigma of A. So the modulus, right? So this that is modulus of R of A is nothing but R of A. I can write, because it is always positive. Okay, non-negative we can say. So instead of mod, I am writing just R of A. You can't write that is. Is that okay?
Yes, ma'am.
And what is the solution? Iterating this inequality and using what is C1 at 0? It is 1. We get what we get? What is mod of C1t? Is less than or equal to spectral radius of A raised to t, right? This is the solution, and spectral radius of t is less than delta, so I can write delta raised to t for all t greater than equal to 0. Is that okay? What is my this one? You can see we have started with delta such that spectral radius of delta and which is strictly less than 1. Is that okay? Also, what is C2 at t plus 1? It is lambda 2 C2t plus lambda 2 C2t plus C1t, no? Lambda 2 or C1t plus lambda 2 C2t. Okay. Lambda 2 plus C1t. Okay. Again, and with what is C2 at 0? It is 0. So this implies I can write this as modulus of C2 at t plus 1 is less than or equal to spectral radius of A times mod of C2t plus mod of C1t I can write. Is that right? This will be less than or equal to spectral radius of A times C2t plus this is nothing but R of A raised to t. Is that right? So again iterating and since C2 at 0 is equal to 0, that mod of C2t is less than or equal to t times spectral radius of A raised to t minus 1 for t greater than equal to 0. Can I write like this? I will show you rough part. What is this? C2 at t plus 1 is equal to spectral radius of A C2t plus R of A raised to t. So what is the solution for this? How we find solution? We know that its solution y at t plus 1 is equal to p of t times y at t plus r of t. And the solution, we know that if y at t plus 1, then its solution is given by yt can be written as ut times summation rt divided by eut plus c, right, where ut is solution of homogeneous corresponding homogeneous equation. Is that right? So what will be the solution here? So So if I consider this star corresponding homogeneous equation, what is corresponding? C to t plus 1 is equal to R of A times C to t. Then what is its solution? Ut must be, corresponding ut must be R of A raised to t, right?
Yes, ma'am.
So therefore yt will be, what is yt? Ut R of A raised to t summation R of t. R of t is my right hand side, is my R of A raised to t, and what will be this? R of A raised to t plus 1, right? EU of t plus constant c. So what will be this? R of A raised to t summation 1 upon uh, 1 upon R of A plus c, right? So c will be 0 because c to t is 0. So I no need to write this one. And since R of A is constant, what will be this? R of A raised to t minus 1 summation 1. So what will be this? T times R of A raised to t minus 1. Is that okay?
Yes, ma'am.
C is 0. Is that okay?
Yes, ma'am.
Yes, ma'am.
So we have written here t times R of A raised to t minus 1. Yt means nothing but my c to t. So C2 at 0 is 0. Therefore, constant should get 0. Whatever may be constant. We can write here or we can. If you write also no problem. If you don't write also no problem. So if I write C, some here will be some C dash, some constant. And since C2 at 0 is equal to 0 implies C dash must be 0. C star you can say whatever. Is that okay? Therefore,
Yes, ma'am.
C2 at t is equal to t times R of A raised to t minus 1. This is just rough part. You no need to write this all things. Okay, so shall I go further? So
Yes, ma'am.
C1t we have got less than equal to delta raised to t, and mod C2t we have got t times R of A raised to t minus 1. Mod C2t is less than or equal to t times R of A raised to t minus 1 for t greater equal to 0. Now again, this is less than or equal to t R of A by delta raised to t minus 1. Delta raised to t minus 1 I can write, divide and multiply by delta raised to t minus 1. Is that okay?
Yes, ma'am.
Now since R of A is less than delta, since r of a is less than delta, strictly less than 1, we must have implies t times r of a by delta raised to t minus 1 will tends to 0 as t tends to infinity. Therefore, thus there exists constant b1 strictly greater than 0, so that mod of c2t is less than equal to b1 times delta raised to t for t greater than equal to 0. Every convergent sequence is bounded. Every convergent sequence is bounded. So I will get t times r of a by delta raised to t minus 1. I can write it is less than or equal to some b1. And since I am writing less than or equal to delta raised to t minus 1, I can replace by delta raised to t. So there exists constant b1 such that mod of c to t is less than equal to b1 delta raised to t. Similarly, we can show that for t greater than equal to 0, mod of c3t is less than or equal to t times t minus 1 by 2 r of a raised to t minus 2. How I can say like this? Again, say rough part. Are you there, students?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Ma'am.
Yes. So how I can write this? Mod of c3t is less than equal to t minus 1 by 2 r of a raised to t minus 2, because we know that c3t plus 1 satisfies the equation. What it satisfies? C2t plus lambda 3 c3t, and c3 at 0 is equal to 0. Again you apply so c3t plus 1 is less than or equal to mod of c2t plus r of a times mod of c3t. I can write. Is that right? So what is the c3t? C2t is what? C2t we have got as t times r of a raised to t minus 1, right?
Yes, ma'am.
So what should be C3t?
C3t is less than or equal to.
Again we have to use that formula, whatever we did here for C2. याच्यासाठी जसं केलं ना आपण आता ut times summation r of t upon eu of t. Okay, so if I use that, what I will get? R of a raised to t. Homogeneous चं solution तेच असेल, r of a raised to t, and summation. Now my RHS changes. RHS is C to T. C to T is nothing but T r of a raised to t minus 1 divided by what is that? R of a raised to t. You add t plus 1 na? You add t plus and plus some constant C. Is that okay?
Yes, ma'am.
So what will be this? R of A raised to T summation T divided by
Alright.
T divided by R of A only, na?
Yes.
It's a T plus 1. Here it will be T plus 1, so here it will be square
Yes.
and plus some constant. Now R of A raised to T summation T, this I can write as, I taken R of A raised to 2 outside, 1 upon. So it will be R of A raised to T minus 2 summation T plus C. C नाही येणार आता हे C some stars again you can say some, because I am taking it outside. Is that okay? दोन्हीकडून
Yes, ma'am.
कॉमन काढला तर what is C star? What will be C star? C times R of
C
A raised
into
to 2,
R of
right?
square. Yes, ma'am.
It is just constant. So what will be this? R of A raised to T minus 2. What is summation T? Summation T is nothing but T minus 1 divided by 2. Is that right? And plus some C star. So, and since C3 at 0 is equal to 0, it implies that constant is 0. Therefore, what is C3T? It is nothing but R of A raised to T minus 2 T minus 1 by 2. That only I have written. T minus 1 by 2 R of A raised to T minus 2. Is that okay?
Yes, ma'am.
So again, it follows that there is a constant B2 such that mod of C3T is less than or equal to B2 times delta raised to T. Same logic. So continuing in this way, so what I have to do now? I have to calculate C4 mod C4T, mod C5T, mod CNT, and so on. So for Cn, I will get one constant. Say it is Bn. Okay. So continuing in this way, we obtain a constant B star greater than 0, so that mod of CIT is less than or equal to B star delta raised to T, where T greater than or equal to 0. What is this B star? B star is maximum. I can take maximum of B1, B2, B3 and Bn. So there exists constant B star such that mod of CIT is less than or equal to B star times delta raised to T. Is that okay?
Yes,
I is
ma'am.
equal to 1 to n. 1 to n. Now, for any matrix M, there exists a constant d greater than 0, so that this is from matrix norm, mod of m times v is less than or equal to d times modulus of v. For all v belongs to Rn. This theorem comes in complex numerical analysis. In any numerical analysis book, you will find this one matrix norm. For any matrix M, there exists a constant d greater than 0, so that mod of v, mod, or you can say any norm, matrix norm, m times v is less than equal to d times mod v for all v belongs to Rn, or norm. Instead of mod, you can say just matrix norm, where this is the matrix norm. So finally, we have given number. Uh, from 2, you can give number to this 3, and for this 4. So using 3 and 4, equation 2 becomes, what is equation 2? Mod of ut is less than equal to summation I is equal to 0 to n minus 1 mod of ci plus 1 of t mod of mi u 0, which is less than or equal to summation I is equal to 0 to n minus 1. What is this? Mod of ci plus 1 of t I can write as b star delta raised to t, and this mod of mi v0 I can write as some di times mod of u0. Is that okay?
Yes, ma'am.
Where di is some constant, so which is less than or equal to, I can write as b star is constant, delta raised to t outside because it is independent of I, mod of u0 also I can take outside, summation I is equal to 0 to n minus 1 di. So di is some constant, so I can write that summation finite sum of di's. I can write it as less than or equal to c times delta raised to t mod of u0, where what is c? C is nothing but b star times summation I is equal to 0 to n minus 1 di, some constant. Is that okay? So therefore, what we need to show this one. So we have shown that mod of ut is less than equal to c times delta raised to t mod of u0. Is that right? So and as or since 0 strictly less than delta strictly less than 1, it follows that what should be limit t tends to infinity, ut must be 0. Is that right? This completes the theorem. Is that okay?
Yes,
So
ma'am.
just we have to use here Pazhar algorithm, and we have to find mod of CITs, okay, and mod UT. For mod of UT, we will require mod CI plus 1 of T and MI U0. Is that okay?
Yes, ma'am.
So remark, okay, when all solutions of the system go to origin or tends to origin as t tends to infinity, the origin is said to be asymptotically stable. So what can I say from this theorem? If spectral radius of A is strictly less than 1, that is the necessary condition for this type of stability. Is that okay? So if I want to say check whether origin is asymptotically stable, then I need to check all solutions goes to origin as t tends to infinity. When it will go when it will tends to 0 as t tends to infinity, from this theorem, if spectral radius of A is strictly less than 1. So whenever we want to check whether some model is asymptotically stable or not, then we find its eigenvalues. If all eigenvalues are instead of all eigenvalues, if spectral radius of A is strictly less than 1, or if all eigenvalues are also less than 1, then spectral radius of A will be automatically less than 1, and then we from this theorem we can say that all solutions goes to origin as t tends to infinity.
Infinity.
Is that okay?
Yes, ma'am.
Okay, so remaining things we will see tomorrow. So that much is enough for today. Let me download the attendance. Okay, so if any doubts you can ask, or if no doubts then you can leave the lecture.